Back. So for this episode, this is a part four of this series. Part one, we did an exploration on one of the data sets. Part two is also another part two, another data set we explored it. Part three, we combined them and then we extracted a file. And that file, we will be using it in this part where we will build a model just to do text embedding. And this is now we've done with the recap. So let's talk about our agenda today. So our goal is to embed the tender using a text semantic sentence transformers or sentence transformers where I can where and we also want to build an FISS vector search index. And we also want to do is we're going to do a split where it's we're going to do a training data, and we're also going to evaluate our prediction using a test data. So for our training, our goal is to use the title and the overview. And for our inference, where for example in the future where we're going to use the user input, is just going to be the title. So for our model, we are going to use the ALMPNet base V2. It is a high accuracy semantic similarity, and our goal is just to convert it to vector, to convert the semantic and the whole sentence into vectors. And from these vectors, we'll put it in a vector space. And then whenever we do a search, we will look for the index of those vectors and find any if our input is nearby any of those indexes, and then and then obtain those indexes. So the goal is to get top five. The reason why we want to get top five is because most of our data is about 30% of our data we have where the one vendor could have many categories, and our goal is to predict categories. So if we were to if our user input were to get one category, and our training data is one vendor has one category, then it would be easier to do a semantic search where we can get just one. But in this case, we are just going to do a cosine similarity to just get as much. We're going to get five outputs, and then the agent will choose from those five outputs. Now that we have been clear, we will be splitting the data into 80 and 20 tests. You can also We are going to also use a stratified sampling technique where we just take each class of our category, and then we take a bunch of samples for it, and then it's just so that we can have an even splitting. So also we are going to evaluate if we can use a multi-label aware, just so that we can account for the cases where one vendor can have multiple outputs, or one input can have multiple material codes. Yeah, so let's get started. First off, we just install the dependencies. I'm just installing the sentence transformers and the indexing. And then we import the libraries, and then we configure it. One thing to bear in mind if you are coding along, or if you are using this you are using this code, change the run type to T4 GPU later on. It will be very we can change it now so that later on when we start the training, it doesn't take long. So we upload the file. This is the gits model ready CSV. If you need this file, you just rerun the previous video, and you should be able to get that file at the end. Now, once we have rerun that, here it is. It's 28,200, and then here is our data set. And our goal, like I mentioned, is for training. We'll be using the title and the overview, and our goal is just to predict the classification, the UNSP classification code. So, as I mentioned, sometimes we will have one of the titles, but then it will have multiple classification codes. So having a one-to-one output is quite difficult in this case. So moving on, we are just going to prepare the text fields. So we are going to use the first. We just fill in the uh, the missing parts with empty space. This is because we have an 1800 missing overviews. Now, the overview will just play a role as enriching the title. It's not mainly for prediction. We just want to add in as much information into that vector space. And for our query text is going to be the X value of what the user inputs. So we are going to use the title only. Now, for here, we are just configuring it. It's a simple configuration. We're combining it and doing a simple string interpretation. And yeah, and here it is, just a simple explanation I added. Now we are going to split it also for the train and test. We are going to uh, and we are going to use we're yet to use here. We are going to use stratified sampling technique just so that we can represent most of the classes in the data set. So here is our split. It's nearly 80/20, is more like 80.3 and 19.7, but it's close enough. 22,000 for the training, and for the test is 5,000. And yeah, so once we generate the embeddings, we're going to load in the sentence transformer model. This is the model name. And then we are going to train it. This is here, we're just loading the model. And then over here, we are going to be training it on batches. Now, the batch size is 256, and then the shape is going to be 768. This is the dimension of the vector that we generate. Now, moving on to the embedded, we're also going to embed the test set as well, but we are just taking the titles only. As you can see here, from the DF test, we use the DF test up there when the splitting. Yeah. And moving on to the DF test, and then we just batch embed it, and perhaps in the future we're going to embed it for each user input. Now, once we have done that, we have embedded everything, then we are going to index those embeddings in the vector space just so that we know where each of these embeddings are. So first we just normalize it, and then after we normalize it, we build the index following the dimension of the indexed the embeddings. And then once we have indexed everything, you can see the uh, index flat IP. This is, we are going to use cosine similarity for the vector space to find. Now, we define the vector search function is a very simple function where we just take in the embeddings, the query embeddings, turn it into 32, float 32, and then find the top k number of inputs. In our case, we're going to be using 1 and then 5. 1, 3, and 5. So we have defined the function, and then once we do, now we are going to use the evaluation just to see how the output is. So my goal is at least to get the metric for the top 1 accuracy, the top 3, and top 5, and then for the top 3 results, or top 5, or even number 1 result. So let's training. So once we call the goal is to come out. For example, if you were out of the 13,000 titles, I want to get, for example, here the top three. I want to get three material groups of there. Here's an example of an input. So we can start off with calling the multi-label. Here I'm testing it on the test set, which is the 5,000. So after running it on a test set, I found out that the top 1 accuracy is 74, and top 5 accuracy is 86. Now, there is some noise in the data set, and I'm guessing this is why it's not fully 100%. And also the another case is that, like I mentioned, we can have one title can have multiple material groups in our training data set, so it considers it. Sometimes it gets sucked into another material group. So moving on to the sample predictions, here is some sample predictions. It's doing good out of a 10. I have it seems like it's 6 out of 10, but since we are using multiple categories, it will be easier. We just want to make it short for the procurement agent or the procurement officer to skim through the material groups instead of just going through everything. So now for the test queries, I just did a simple test queries. I grabbed these from the data, the test sets, and then I can see is that somehow it's giving me somewhat consistent output, but it kind of takes kind of if you put like two different things, like for example, you're going to put office furniture and equipment, then it will sometimes give you the material codes that is related to office furniture and material codes to related to furniture, and also it will give the another material groups like freestanding furniture and desk supplies. Now this the model does not can tell some difference, but you still need a human intervention. Can't fully automate it. It's just that we are speeding the process to get those. And here's another example where we are highway construction service, road maintenance and highway construction. So here we took highway and road construction services, roads and landscape, and professional engineering. I don't know where this came from, but we also have roads and landscape. Sometimes it gives it a repetitive. This is where we can increase the accuracy. I guess it's easier for the agent to identify it. And yeah, so here I did multiple examples, and I also did a custom query where there is no such text in the data set, and it somewhat gave s- in the ballpark. So, for example, provision of security and guard services, it says national defense, public security and safety services, guard services, and it kind of repeated these, and security surveillance detection. So we have three repetition and then two unique codes. So I guess the agent can just select which ones are the best later on. So finally, we are saving the embeddings to different types just so that we can use it later for Gradio. We don't really need all of them, but I'm saving it anyways just so that I don't have to rerun the trainings all the time. So that is about it for building the model. Please leave a comment in case you're stuck in something. And yeah, so see you in the next video. Bye bye.